Hello guys, welcome to my channel. This channel is going to help you prepare for your AP Calculus AB and AP Calculus BC. And the topic we are considering today is Unit 1, which is limits. So let's delve in. Feel free to subscribe and like this channel so that you don't miss any videos. We'll be reviewing past AP practice exam questions on all the units. So after this video, you will see another video which has to do with all past questions on limits and how to approach those questions. This video is a teaching video where we are going to give you in-depth analysis of in-depth understanding of limits and the way to approach questions on limit. So it's a teaching video, so follow along as we get a deeper understanding of limits. My name is Prince. I have a PhD in mathematics and you are welcome. So limit, we are going to be looking at the numerical approach of solving limits, the graphical approach of solving limits, and the analytic approach of solving limits. So someone will ask, what is limit? So if I have a graph of a function, let's say this function is f of x, even though this graph is the graph of y equals to x, let's just call it f of x for now. And let's say I have the point here 2, and we want to find the limit as x approaches 2. So to be able to find the limit as x approaches 2, first of all, we need to find the limit as x approaches 2 from the left. And we also need to find the limit as x approaches 2 from the right. So clearly you realize that as we approach 2 from the left, the value on the y-axis is what is our limit. So if we track 2 to the graph and track it to the y-axis, the value there is 2. So this tells us that the limit as x approaches 2 from the left of our function f of x is equals to 2. We also need to find the limit as x approaches 2 from the right. And you can clearly see that the limit as x approaches 2 from the right of f of x is also equals to 2. Now, how did we see that? So this is our graph, and you realize that the point here is 2. So this is the right side of 2. As I approach 2 from the graph, as soon as I come from the right hand side to this point, the value that I have here is 2. And as I approach my graph from the left of 2, as I get closer and closer and closer to 2, the value here is also 2. So that tells me that the limit as x approaches 2 of f of x is equals to 2. Why? Because the limit on the left of 2 and the limit on the right side of 2 are the same. Therefore, the limit as x approaches 2 of f of x is equals to 2. That explains it. So that is what we have written here. In words, we said that if the y value of a function f of x becomes close to a single value L, as x gets closer and closer to a point C from both the left and the right side, then the limit of f of x as x approaches C is L, which can be written mathematically as the limit as x approaches C of f of x is equals to L. So someone will ask, when does a limit exist? So a limit exists when the left-sided limit is equal to the right-hand-sided limit. So if these two limits are equal, then we say that that limit exists. And that is what is explained here. So a limit exists if the limit as x approaches C from the right is equal to the limit as x approaches C from the left. If these two are the same, then we say the limit exists. So the limit of f of x as x approaches C from the right is equal to the limit of f of x as x approaches c from the left. If the two are the same, then we say the limit exists. Another way to represent this is if the limit as x approaches c from the left of f of x is equal to k, and the limit as x approaches c from the right of f of x is equal to L, then we say that this limit will exist if k is equals to L. That means the limit exists. The limit does not exist if k is not equal to L. Then the limit does not exist. So if k is not equal to L, then we say the limit does not exist. Great. So now that we understand the definition of limits, let's look at two more other definitions or two more other terminologies, and we proceed to an example. So the two other terminologies I would like to look at here is a function. Now a function is either defined or undefined, and a limit either exists or does not exist. So these are the two terminologies that you need to know. So a function can either be defined or undefined, and the limit can either exist or does not exist. Now, when do we say a function is defined? A function is defined if we have a value for that particular function at a particular point. So for example 1, I have here f of x. This function f of x is defined at all values of x except when x equals to 1. So when x equals to 1, you see that this function is undefined. Why? Because you are going to be dividing by 0 on the denominator. And when that happens, we say the function is undefined. So this function is undefined at the point x equals to 1. And this function is defined at all other points except x equals to 1. So let's find the limit as x approaches 1 of this particular function, first using the numerical approach. So with the numerical approach, what we do is we are going to substitute values that are on the left hand side of x and values that are on the right hand side of x. And we are going to check to see what value are we getting as we approach x from the left and from the right. So we begin by substituting x equals to 0.75 into our function f of x. And when we do that, we get 2.313. We again substitute 0.9, we get 2.710. We substitute 0.99, we get 2.970. We substitute 0.999, we get 2.97. Clearly, you can see that as we approach x from the left, we are approaching the value 3. Why? Because if you approximate this value, it's 3. This is 3. So as we approach 1 from the left, we are gradually approaching the value 3. Now, even though when you substitute x equals to 1 into the function, you get an undefined value, you realize that as we are approaching 1, we are getting 3, even though the value here is undefined. Okay, now let's check the values we get when we approach 1 from the right. As we approach 1 from the right, clearly you can see that we are approaching 3. So this tells us that the limit as x approaches 1 from both the left of our function f of x is equals to 3, and the limit as x approaches 1 from the right of our function f of x is also equals to 3. So clearly that tells us that the limit as x approaches 1 equals to 3. And that is the numerical approach of considering limit. Now it's a lot because you have to keep substituting values, create a table and keep substituting values to see what particular value is your limit approaching. Now let's look at the graphical approach. With the graphical approach, it's pretty much simple. We have the graph of the function f of x that we want to find the limit as x approaches 1. And clearly you can see that there is a hole at this point. The hole here tells us that the value as x equals to 1 is undefined. So there is no defined value when x is equals to 1 in this particular function f of x. But the limit exists. So you see that if I approach, this is 1, so this is the left hand side of 1, and this is the right hand side of 1. So if I look at the left side of 1, if I go on the graph and the left side of 1, as I approach 1, this point here is 1 according to this. So as I approach 1 from the left hand side of my graph, the value I get is 3. And as I approach 1 from the right side of my graph, the value again I get is 3. So that tells me that the limit as x approaches 1 is 3. And this is the graphical approach to finding limits. Let's look at another example to help you understand. And comment down below if you would like to have the PDF to this study material. I can send it to you by email. So let's look at example 2. So with example 2, again, we have a function that we want to evaluate the limit of this function. And we are going to do this using, first of all, the graphical approach this time around, and second of all, the numerical approach to see whether we'll get the same set of answers. So with the graphical approach, I have the graph of the function we are going to find the limit here. Now, before we look at the graph, you can clearly see that if you substitute x equals to 0 into this particular function, you realize that you get an undefined value. Why? Because you're going to end up with 0 divided by square root of 0 plus 1 minus 1. And this will give us 0 divided by 1 minus 1, which is 0 over 0. And 0 over 0 is undefined. We don't know the definition of this. So clearly, we have a function which is undefined. But does it mean the limit does not exist? No. Even though the function is undefined, we can still go ahead to find the limit. So let's do that. So I'm going to find the limit as I approach 0. Now this is 0. Here represents 0 on the x-axis. And this is the left side of 0. And this side is the right side of 0. So any part of this graph which is on this side is on the left-hand side of 0. And any part of the graph here is on the right-hand side of 0. So as I approach 0 from the left, clearly you see that the value I have here is 2. And as I approach 0 from the right, the value I have here again is 2. So this tells me that the limit as x approaches 0 from the left of f of x is equals to 2. And it also tells me that the limit as x approaches 0 from the right of f of x is equals to 2. So therefore, the limit of f of x as x approaches 0 is equals to 2 from the graphical approach. So as I approach 0 from the left, the value I get is 2. As I approach 0 from the right, the value I get is 2. Now let's go ahead and look at the numerical approach. So with the numerical approach, again, we keep substituting values on the left-hand side of 0, which are negative values, and we substitute values on the right-hand side of 0, and we monitor at what value are we approaching. So again, when you look at the left-hand side of 0, you have negative 0.01, negative 0.001, negative 0.0001, as we get closer and closer to 0 from the left side. And you see that these values are gradually approaching what? 2. If you approximate these values, you'll definitely get 2. Now let's consider the right-hand side. So as I approach 0 from the right-hand side, again, you see that these values are gradually approximating to 2. So that tells us that as we approach 0 from the right, our value is 2. Now, even though when we substitute 0 directly, we are getting an undefined value. So this tells us that even though the value is undefined, when we substitute 0 directly, the limit still what? Exists. The limit exists. And what is the limit? The limit is what? 2. So this is how we solve the same question using the numerical approach. And all this is to help your understanding of limits. So that is example number 2. Let's move on to example number 3. So with example 3, this time around we'll not look at the numerical approach. You are going to consider only the graphical approach, so you understand it carefully. So again, we want to find the limit of f of x as x approaches 2. Now this is the function that we have. So our function is a discontinuous function. So when we mean discontinuous, it means there is either a hole, a jump in our function. There is a hole or a jump in our function. Now, specifically with this particular function, there is a hole in this function. That's why we have this hole here. So we call this the hole, like a pothole on the road. So, how do we find the limit as x approaches 2? So the question is, we want to find the limit as x approaches 2 of f of x. And that is what we are looking for. So how do we solve that? To be able to solve that is simple. First of all, we need to find the limit as x approaches 2 from the left. So the limit as x approaches 2 from the left of f of x. And to do that, we go to the graph. This is 2, and everything here is the left side of 2. So as I approach 2 from the left side, the value on the y-axis is the value that I'm picking. So the value here is what? Is 1. And again, we find the limit as x, the limit of f of x as x approaches 2 from the right. So as x approaches 2 from the right, this is the right-hand side of 2. So as I approach 2 from the right, the value I get is the value on the y-axis, which is what? Again, 1. So this tells me that the limit as x approaches 2 of f of x is equals to 1. And this is how we use the graphical approach to find the limit. And the next point is, when does a limit fail to exist? Limits that fail to exist. When do we say the limit does not exist? As we saw earlier, we said the limit does not exist when the limit of f of x as x approaches c from the left is not equal to the limit of f of x as x approaches c from the right. If the two are not the same, then we say the limit does not exist. Great. So let's look at examples of limits that does not exist. So we have to show that the limit of the function absolute value of x over x as x approaches 0 does not exist. To show that, we need the graph of the function absolute value of x divided by x. And this is the graph. Now, clearly from this graph, you realize that this is 0 again, and this is the right hand side of 0. And this is the left hand side of 0. So if this is the right side of 0, now let's find the limit as x approaches 0 from the right. This is the part of the graph which is on the right side of 0. So we are going to use this graph. So as we approach 0, remember this is 0, so this line here represents 0 on the x-axis. This is the line x equals to 0. So as we approach 0 from the right side of the graph, the value we get is 1. So that tells us that the limit as x approaches, the limit of absolute value of x divided by x as x approaches 0 from the right equals positive 1. Now let's look at the limit as x approaches 0 from the left. This is the left side of 0 and this is the left-sided graph. So as we approach 0 from the left, the value we have here is negative 1. So that tells us that the limit of absolute value of x over x as x approaches 0 from the left equals negative 1. Now these two values are not the same. Both the left-handed limit and the left-sided limit and the right-sided limit are not the same. So because they are not the same, we will say that the limit as the limit of absolute value of x over x as x approaches 0 equals to does not exist. Why? Because the limit, the left-hand sided limit, is not the same as the right-hand sided limit. Therefore, the limit does not exist. So this is one type of limit that does not exist. And this type is what we call both the left and the right-handed limit are not the same. So if you have a limit where the right-hand sided limit is not equal to the left-hand sided limit, then we say that limit does not exist. There is another type which we call the unbounded behavior. So let's look at that example, example 2. And this is another type of limit that does not exist, unbounded behavior. And what is that? Clearly, we want to find the limit as x approaches 0 of our function 1 over x squared. And this is the graph for the function 1 over x squared. Looking at this graph, this is 0. So the y-axis is the line x equals to 0. Now, this part is the right-hand side of 0, and this part is the left-hand side of 0. So if we consider the right-hand side of 0, there's a limit of 1 over x squared as x approaches 0 from the right. Now you can see that as we approach 0 from the right, we are getting closer and closer to 0. We keep going, we never get close to 0. This graph keeps going. It's asymptotic to the line x equals to 0. So it keeps going without bound. So it's unbounded. Because it's unbounded, we don't know where it is going. It doesn't go to any specific value. So because it does not go to any specific value, we do not have an answer to that. Now, if you also consider the limit as x approaches 0 from the left of 1 over x squared, the same thing happens. is unbounded. It keeps going on and on and on without approaching any specific value. And therefore, we conclude that the limit as x approaches 0 of this particular function does not exist. The limit as x approaches 0 of 1 over x squared does not exist. So watch out for unbounded behavior. We'll look more into this when we look at limit as x approaches infinity. Now you'll be tempted to say it's going to positive infinity. No, it's not going to positive infinity for now, for your understanding. Okay, so we'll move on to the third behavior of limits that do not exist. And the third behavior of limit that do not exist is the oscillating behavior. You have the function oscillating between two values. So a typical example is the limit of sine 1 over x as x approaches 0. Again, this is a graph of our function sine 1 over x. Clearly, you can see that this is 0. And as we approach 0, you can see this limit keeps going between -1 and 1, -1 and 1, -1 and 1 as we approach 0 from the right. As you approach 0 from the left, it also keeps oscillating between -1 and 1, -1 and 1 as we approach 0 from the left. So we don't have a specific value that we can pinpoint this limit to. As a result of that, we say that the limit of sine 1 over x as x approaches 0 does not exist. Why? Because it's oscillating between -1 and 1. And this is the numerical table to help you understand. Clearly, you can see that as we keep substituting values, as we approach x equals to 0, the values, the answers we get is +1, -1, +1, -1, +1, -1. Therefore, the value, the limit as x approaches 0 does not exist. So these are the three main categories of functions where the limit does not exist. And we've summarized them here. The first type is f of x approaches a different number, the right side of c, than it approaches on the left side. And that's the first example we saw. Then the second type is f of x increases or decreases without bound as x approaches c. So it keeps increasing without bound as x approaches c, or it keeps decreasing without bound as x approaches c. Even though the two values are heading towards the same direction, we don't know where they are going. So because of that, we say that the limit does not exist. Number 3, it's oscillating between two fixed values or two fixed points. A typical example is what we just saw. It's oscillating between -1 and 1. When that happens, we say the limit does not exist. So let's move on to finding limits graphically. Let's have more examples on how to find limits graphically. So we want to find the limit of 4 minus x as x approaches 3. So this is example 1. So clearly you can see that we have the graph of f of x here. 4 minus x. Now we look for x equals to 3, which is this value, and we trace it to the graph, that is this point. So this part is the left and this part is the right. So as I approach 3 from the right, the value I have here is 1. And as I approach 3 from the left, the value I have here is 1. So clearly this tells me that the limit of 4 minus x as x approaches 3 is +1. And that is the answer. Now someone who asks, what is this shaded dot? This shaded dot is the value of f of 3. It tells us the value of f of 3. So the value of f of 3 is also equals to 1. And we'll look at this when we deal with continuity. So let's solve question 2. Question 2, we want to find the limit of sec x as x approaches 0. So clearly, you can see that this is 0, the right side of 0, and this is the left side of 0. So as I approach 0 from the right, the value I get here is 1. And as I approach 0 from the left, the value I also get is 1. So that tells me that the limit of sec x as x approaches 0 is equals to 1. Let's look at example number 3. So example 3, we want to find the limit of f of x as x approaches 2. And this is our function f of x. And this is the graph of f of x. So clearly we can see that we have to locate our value 2. This is the value 2. And if you substitute x equals to 2, you realize that there is a hole in the function at a point. So we approach 2 from the right, and as we approach 2 from the right, the value we get is 2. And as we approach 2 from the left, the value again that we get is what? Is 2. So that tells us that both the left-sided limit and the right-sided limit are equal. So the answer to this will be equals to 2. And again, here, what is this dot? This dot represents the f of 2. So in this particular case, f of 2 is equals to 0. And because these two are not the same, we say that the function is not continuous. So if you look back to example 1, you realize that these two values are the same, so we say the function is continuous. It's a continuous function. And we'll look at that within this unit. Now let's go ahead to look at example number 4. In example number 4, we want to find the limit of f of x as x approaches 1. Again, this is the function f of x, and this is the graph of f of x. So we locate our value 1, which is this value on the x-axis. And as we approach 1 from the left, you see that the value we have is this value here. And clearly, if from here to here, this is 2, this is 6, so clearly we know this value here is 4. So as we approach 1 from the left, the value we get is 4. And as we approach 1 from the right of our graph, again, we are getting the same value, which is 4. So this tells us that the limit of f of x as x equals to 1 is 4. Now, what is f of 1? F of 1 is this shaded dot that we have here. So it means that if we substitute the value x equals to 1 into our function, the value that we'll get is this value, which is 2. So if f of 1 is equal to 2, these two values are not the same. F of 1 and the limit as x approaches 1 are not the same. So we say that this is a discontinuous function. It means this function is not continuous. And clearly you can see that it has a hole. So the next example we have is example number 5. So example 5, we want to find the following values from this particular graph. So again, if you look at this, we want to find first of all f of 1. F of 1 is the value of the function when you substitute x equals to 1. So we locate 1 on the x-axis. So this is 1. We trace 1. Where do we have the dot? The shaded dot is on 2. So that tells us that f of 1 is 2. Then the next question says we should find the limit as x approaches 1 of f of x. So the limit as x approaches 1, again, we go back to 1 on the x-axis. This is the line x equals to 1. So straight line this way. So this is the right side of 1 and this is the left side of 1. So as I approach 1 from the right on the graph, the value I have here is 1. And as I approach 1 from the left, the value I have here is 3.5. So clearly, the two values are not the same. So you can see that the limit as x approaches 1 from the left, you are getting 3.5. And the limit as x approaches 1 from the right, we are getting 1. These two are not the same. So because they are not the same, we say that the limit does not exist. So this tells us that the limit does not exist. The next question says we should find f of 4. So f of 4, we go to 4 and we trace. Now f of 4 does not have any shaded value. So once there is no shaded, this is a hole, it tells us that f of 4 is undefined. It does not have a defined value. Then the next question says we should find the limit of f of s as x approaches 4. So again, to find the limit as x approaches 4, we need to consider both the left and the right hand side of 4. So this is the line x equals to 4. So this is the left side of 4. As we approach 4 from the left, the value we are getting is 2. And as we approach 4 from the right, again, the value we have on the y-axis is 2. So this tells us that the limit as x approaches 4 is equals to 2. And because these two values are again not the same, it tells us that the function is not continuous at x equals to 4. And clearly you can see that it's not continuous. Again, you also see that f of 1 is 2. And the limit of f of x as x approaches 1 does not exist. So it tells us that the value is not continuous at x equals to 1. And you can see that there is a big gap. So this explains how to find limits graphically. Let's look at another example which will help you perfect this, and then we proceed. So this is another example of finding limits graphically. Again, we have our graph. We are going to use this graph to answer the following questions. So first of all, we want to find f of negative 2. So we go straight up to negative 2 and we locate any shaded point, or when the graph cuts through this line, where does the graph touches on the y-axis. So the value on the y-axis as this line cuts through the graph, what value do we have on the y-axis? Now clearly you can see that there is a vertical asymptote at x equals to negative 2. So there is no specific value that we have attached to the graph at x equals to negative 2. For that matter, we say that the value of f of negative 2 is undefined. Then the next question says we should find the limit of f of x as x approaches negative 2. So this is negative 2. Now this is the left side of negative 2 and this is the right side of negative 2. So if I consider the left side of negative 2, as I approach negative 2, I don't seem to approach any specific value from the left. And as I approach negative 2 from the right, I don't seem to approach any specific value. The graph keeps increasing unbounded, and the graph keeps decreasing unbounded as I approach negative 2 from the left. And this is a typical example of what we saw of functions that do not have limits. So we say that the limit here does not exist. Okay, so for does not exist, I'll be using D and E for short. Don't do that in your exam. Write does not exist completely. The next question is to find f of 0. So to find f of 0, we locate 0 on our graph and find where the graph cuts through the line x equals to 0. The y value there is our f of 0. So clearly, you can see that even this point is shaded. Even if it's not shaded, once the graph cuts through that point, the value here is what we are going to take. So the value here is 4. So that tells us that f of 0 is 4. Now, we want to find the limit of f of x as x approaches 0. So the limit of f of x as x approaches 0, we go to 0. This is the left side of 0. This is the right side of 0. And this is the part of the graph which is on the left side of 0. Now, as we approach 0 from the left, we see that we are getting a value which is less than 1. Less is 0.5. And this is the right side of 0. As we approach 0 from the right, we are getting 4. So 4 and 0.5 are not the same. So because they are not the same, we say that the limit does not exist. Then, let's continue. Example question E. It says we should find f of 2. So f of 2, we go back to the point 2 on our graph. Now, is there any value which is shaded for 2 on the graph? No. There is a big hole at the point where 2 is exactly under the graph. And this tells us that the value there is undefined. Then the next question says we should find the limit of f of x as x approaches 2. So we are going to consider as x approaches 2 from both the left and the right. So this is the left of 2. This is the part of the graph which is on the left of 2. As we approach 2, the value here is 0.5. Then from the right, as we approach 2, the value again is 0.5. So this tells us that the limit of f of x as x approaches 2 is 0.5. Now let's look at the next one. It says we should find f of 4. So f of 4, again, we locate 4 on our graph. And we look, this is the shaded value that we have. So we trace the shaded value to the value on the y-axis, which is 2. So that tells us that f of 4 is 2. Next one says we should find the limit of f of x as x approaches 4. So we're going to consider both the left and the right. So as we approach 4 from the left, see that the graph keeps increasing unbounded. And as we approach 4 from the right, the graph also keeps increasing unbounded to no specific value. This tells us that the limit is what does not exist. So as I said, limit either exists or does not exist, and a function is either defined or undefined. And this particular example helps you to understand that concept. So let's look at another example of finding limits graphically to help you master this particular step. Then we proceed. So again, we have this huge graph. We are going to discuss how to find the limits. So the first question we have A, it says we should find the limit of f of x as x approaches 0. So I go to 0. This is the line. X equals to 0. So this is the left hand side of 0 and this is the right hand side of 0. So if this is the left side, now as the graph approaches 0, it keeps going. As it gets to 0, which is this line, you clearly see that the value here is 6 from the left. Now from the right, as I approach 0, the value here again is 6. So this tells me that the limit of f of x as x approaches 0 is definitely 6. Why? Because the left-sided limit and the right-sided limit are the same. Great. Let's look at question B. Question B, we want to find the limit of f of x as x approaches 6 from the left. So the limit of f of x as x approaches 6 from the left. So we go to the graph. This is 6. Now, this is the left side of 6. So this is the graph which is on the left side of 6. So as I approach 6, from the left, what value do I get on the y-axis? I get 4. So the value there is 4. Then the next one says we should find the limit as x approaches 2 from the left. So I go to 2, and this is the left side of 2. And this is the part of the graph which is on the left side of 2. So as I approach 2 from the left, the value that I get here on the y-axis is 0. So this tells me that the limit as x approaches 2 from the left is 0. Then the next one says find the limit of f of x as x approaches negative 6. So I go to negative 6. We have to consider both the left and the right side of negative 6. So as I approach negative 6 from the right, the value I get is 0. Clearly. So this is negative 6. The value here is 0. So this tells me that the limit as x approaches negative 6 from the right is 0. Now, what about the left of negative 6? There is no graph for the left of negative 6. We don't have a graph here. So that tells me we don't know the value of that. So the two cannot be the same. And that tells us that this does not exist. Why? Because the left-hand-sided limit and the right-hand-sided limit are not the same. The next question says we should find the limit of f of x as x approaches 1. So we locate 1 on our x-axis, and this is the right of 1, this is the left of 1. As I approach 1 from the left, the answer is 3. As I approach 1 from the right, the answer is again 3. So this tells me that the limit of f of x as x approaches 1 is equals to positive 3. Then the next question says we should find f of 1. So f of 1, we go to 1. Do we have any shaded value? Yes, we have the shaded value here, and that on the y-axis is 1. So that tells us that f of 1 is 1. It says we should find f of 2. So f of 2, we go back to our graph and find 2. Now, is there any shaded value for 2? Yes, there is here, and the answer is 2. So f of 2 is also 2. And now it wants us to find the limit of f of x as x approaches 2. So we again go back to 2. We consider the left side of 2. As we approach 2 from the left, the value we have for the limit is 0. As you approach 2 from the left, the value is 0. As you approach 2 from the right, the value of the limit we have is 2. Clearly, the left and the right-sided limits are not the same. So if they are not the same, that tells us that the limit as x approaches 2 does not exist. So this is an example to help you understand and master the art of finding limits graphically. Let's move on to another example to help you master this art. And this will be our final example on finding limits graphically. So again, we have a huge graph, and we are going to find the limits of this graph. So the first one says, find the limit of f of x as x approaches 0 from the left. So we locate 0, and this is the left side of 0. So we locate what graph is on the left side of 0. And as we approach 0 from the left, the value we have here is 3. So this tells us that this is 3. Question 2, it says we should find the limit of f of x as x approaches 0 from the right. So again, this is 0. This is the right side of 0. These are the graphs on the right side of 0. This is the one closest. As we approach 0 from the right, the value we have here is negative 3. So clearly, you can see that the left-sided limit and the right-sided limit are not the same. So the limit as x approaches 0 does not exist. Let's move on. Number 3 says we should find the limit of f of x as x approaches positive 8. So we locate positive 8, which is this. So as x approaches 8 from the right, from the right. Now we don't have any graph on our right of 8. So no graph. Therefore, we cannot what? Determine the limit. So the limit as x approaches 8 from the right does not exist. Then question 4 wants us to find the limit of f of x as x approaches negative 8. So as x approaches negative 8, we locate negative 8. We have to consider the right side of negative 8 and the left side of negative 8. So the right side of negative 8, as we approach negative 8 from the right, the value we have is 0. And as we approach negative 8 from the left side, the value we have is negative 4. Clearly, the two are not the same, so the limit as x approaches negative 8 does not exist. Then, question 5. So this is supposed to be 5. This is 6, this will be 7. So question 5 wants us to find the limit of f of x as x approaches 8 from the left. So again, we go to 8, and this is the left side of 8. So as we approach 8 from the left, the value we have is what? Is 4. So that tells us that the limit as x approaches 8 from the left is positive 4. Question 6, we want to find the limit of f of x as x approaches 0. Now we're able to find the limit of f of x as x approaches 0 from the left, the limit of f of x as x approaches 0 from the right. The two are not the same, so that tells us that the limit of f of x as x approaches 0 does not what? Exist. Does not exist. Then question 7. We want to find the limit of f of x as x approaches 4 from the right. So again, we locate 4. This is the right side of 4. And as we approach 4 from the right, the value we have is negative 2. So negative 2. And question 8, we want to find the limit of f of x as x approaches 4. We already have the answer to the limit as x approaches 4 from the right. Let's find the answer to the limit as x approaches 4 from the left. So as we approach 4 from the left, the limit, we see that we have positive 3. Now this positive 3 is not equals to negative 2. Therefore, the limit of f of x as x approaches 4 does not exist. And this brings us to the end of finding limits graphically and numerically. The next topic we are going to look at is how to find limits algebraically using the algebraic methods. See you in the next video of finding limits algebraically. If you like this video, please subscribe and click on the like button to get more updates when I upload new videos. Thank you. Stay blessed. Bye.